NASA has shared pictures of something that has never been seen before. A star called Betelgeuse went through a dramatic event and lost a gigantic piece of its surface mass. The space agency says the ejection was 400 billion times the mass of a typical solar flare from our Sun. This event is known as a surface mass ejection, SME. Researchers are calling it watching stellar evolution in real time, because it's so unusual for a star to blow off such enormous parts of its body. This massive eruption from this very red giant is changing part of what we assume we know about the universe. Why did Betelgeuse's top blow off? What will happen to the universe? Let's find out. The stars in a constellation are arranged in a way that's connected to legends and stories. They are still used for navigation today. Betelgeuse is one of these stars. It's one of the largest and brightest in the night sky. Betelgeuse is the name of a brilliant, shining, ruby-red star that can be found in the upper right shoulder of Orion, the Hunter, a winter constellation. Astronomers, on the other hand, see it as a behemoth bubbling over with a regular pulsating beat every 400 days. Betelgeuse is easy to spot due to its deep orange-red color. It's an excellent example to show people who may not believe that stars come in different colors. This star is also called Alpha Orionis, and it's the second brightest star in the constellation. Rigel is the brightest. Despite its changing nature and unusual name, Betelgeuse is a fascinating object to study. Often, stars named Alpha are the brightest in their constellations, but although Rigel, the other bright star in Orion, is actually brighter, Betelgeuse still holds the title of Alpha Orionis due to its size, color, and historical significance. Betelgeuse is one of the most famous stars, inspiring both a character and the movie Beetlejuice. It's the seventh brightest star visible from most of North America, Europe, and Canada, and the 10th brightest star in the entire sky. Earth isn't too far from Betelgeuse. While scientists can't pinpoint the exact distance, they estimate it to be somewhere between 430 and 724 light-years away. It's the largest red supergiant star and the closest of its kind to Earth in our galaxy. There are only about 200 named red supergiant stars. Betelgeuse is enormous. It's wider than the asteroid belt and much larger than Jupiter. If Betelgeuse were in place of our Sun, it would likely engulf Earth, Mars, Venus, and Mercury entirely. The star is 16 times larger than the Sun in diameter and shines with a brightness roughly 100,000 times that of the Sun. However, it's cooler, with a surface temperature around 3,600 Kelvin, which is lower than the Sun. Approximately 13.3% of Betelgeuse's radiant energy is visible light. It's possible that Betelgeuse would be brighter than Sirius at night if our eyes could see all wavelengths of light. Betelgeuse loses roughly one solar mass every 10,000 years. The star is surrounded by a cloud of matter, as it ejects material in all directions unevenly. This haze of matter is over 30 astronomical units across, roughly the distance between the Sun and Neptune, the farthest planet in our solar system. The Sun often sends out large quantities of matter into space in events called solar flares. However, the Sun only ejects small portions of its upper atmosphere, known as coronal mass ejections, CMEs. This recent ejection from Betelgeuse, however, is classified as a surface mass ejection, SME, and it's on a much larger scale than typical solar flares or CMEs. The crown is the name for the CME that is created when a star loses some of its unsteady external environment. CMEs from our planetary group happen constantly and can influence Earth and individuals who live there. CMEs can send magnetic fields and plasma into space at velocities of more than 1,800 meters per second. This means that sometimes they can reach Earth in just a few hours. When it happens on the side of the Sun that faces Earth, a CME can damage and disrupt Earth's satellites and power grids. It can also endanger people in orbit. The recent discovery shed light on the peculiar reason why Betelgeuse dimmed in 2019. The star lost matter that burst into space, creating a cloud of cosmic dust that blocked observers on Earth from seeing how bright Betelgeuse truly was. Also, Betelgeuse's famous consistent pulsation pattern has changed. Betelgeuse's CME was different because it released 400 billion times more mass than a typical CME, making the star shake like a dish of gelatin dessert. According to a NASA news release, astronomer Andrea Dupree from the Center for Astrophysics says the star's internal convection cells may be in turmoil, while the photosphere, which we consider the star's outer layer, struggles to rebuild itself. For recent years, astronomers have been monitoring the star's steady pattern, but it no longer seems stable. Red giants like Betelgeuse are dying, and scientists will be able to learn a lot about how stars change over time by watching this process. Most stars in the universe derive their power from nuclear fusion. When this process runs out, the star undergoes various fascinating changes before it finally dies. When a star is first formed, it is composed of hydrogen. Gravity pulls the hydrogen together in the star's core, where it fuses into helium. This fusion process releases a lot of light and heat energy, which then travels to the star's surface and is sent into space as photons. As the star ages, hydrogen, the star's main fuel, runs out. When all the helium is exhausted, carbon will eventually combine with neon to make iron. When this happens, energy is absorbed rather than released. This leads to the collapse of the star's core, resulting in a supernova explosion, one of the most powerful forces in nature. It can release more energy than 10 billion suns. As stars age, they change color, moving from the hottest blue types to cooler red types. The color change depends on the stage of their evolution. Greek scientist Tuai around 168 AD noted that Betelgeuse's color was reddish, but Chinese scientists had said the star appeared yellow 300 years earlier. This could mean that Betelgeuse used to be a yellow supergiant. Although only around 10 million years old, larger stars like Betelgeuse burn through their hydrogen more quickly and die sooner. There's no doubt that Betelgeuse is nearing its end. In contrast, our Sun is about 5 billion years old, still in its prime. A supernova may happen soon, as Betelgeuse is close to the end of its life. Betelgeuse undergoes 2 cycles of dimming and brightening, with the second one occurring roughly every 6 years and lasting for about 100 days. It's thought that the star's outer shell expands and contracts during this cycle, changing the star's diameter and average temperature at each stage. Astronomers might learn more about how red stars lose mass in their final days before they explode in a bright supernova. From Betelgeuse's eruption, scientists observed a large mass ejection on a star's surface for the first time. There is still something going on that we don't fully understand, Dupree says. We can see this fresh effect directly and clearly with Hubble, which helps us see surface features. We're observing the evolution of stars in real time, but because the results are so unusual, it's unclear if this means Betelgeuse is about to go supernova. A warning from NASA states Betelgeuse may not be dead yet, even if it appears so. NASA says that red supergiants die relatively quickly compared to the rest of the universe. In 100 years, Betelgeuse will likely go supernova. Betelgeuse has been the subject of much research since the 1st century BC. Recently, a scientist named Serafina Nance and her team tried to determine when red supergiants like Betelgeuse might explode as supernovae. They did this to understand how a star that massive would behave over time. Nance and her team used Betelgeuse as a model for various scenarios, then compared their results with field observations. Betelgeuse's luminosity decreased rapidly, deviating from its usual cycle. It probably won't explode for another 100,000 years. Years ago, Betelgeuse was removed from its home in the Orion OB1 association, which is comprised of the stars in Orion's belt. It has been observed moving at 30 kilometers per second through the space between the stars, creating a bow shock that is over 4 light-years wide. This bow shock is caused by the quick-moving star. Starting in October 2019, Betelgeuse began to dim significantly, losing about 3 times as much light by mid-February 2020, going from a magnitude of 0.5 to 1.7. By February 17, 2020, Betelgeuse had remained constant in brightness for nearly 10 days, and the star began to brighten again 5 days later. However, Betelgeuse didn't seem to be dimming at all, which implied that the darkening episode was over. Since there were no major changes in the infrared on February 24, 2020, it appeared that the recent loss of visibility was not due to the expected core collapse. On the same day, another study found that the star's dimming was likely caused by large grains of dust around it, which were blocking the light. A study using submillimeter wavelength readings suggested that dust absorption could not have a major impact. Rather, the dimming seemed to be caused by large star spots. Further research showed that, between May and August, Betelgeuse became significantly brighter. This star is so close to the Sun that it will be difficult for people on Earth to see it before 2020 when it aligns with the Sun. In June and July 2020, it was observed at a magnitude of plus 0.4 by the SOHO satellite after being last seen from Earth in April, at which point it had dimmed by 0.5 magnitude. This surprised astronomers, as the peak brightness was expected in August or September 2020, with the lowest brightness around April 21st. It was known that Betelgeuse's brightness could change wildly, which made it difficult to make predictions. It appears that this dimming indicates there may be a second darkening event sooner than previously thought. In August 2020, scientists announced that they had discovered a second dust cloud originating from Betelgeuse. This cloud was associated with a recent large dimming of the star's light in June 2020, and it was suggested that the dust might be coming from a cool spot on the star's photosphere. In August, a second independent study confirmed the initial hypothesis. Studies conducted with the Hubble Space Telescope in 2019 and 2020 suggested that the dust may have been created by gas expelled by the star. For example, a surface mass ejection could have created the dust. Material was ejected from the star's surface, then cooled, solidified, and became part of the star's dust. When the photosphere broke, it sent mass, several times heavier than our moon, into space, where it cooled and formed a dust storm that blocked the star's light from Earth. The dimming began in late 2019 and continued for a few months. Even backyard observers could clearly see the change in the star's light. More astounding is that the supergiant's 400-day pulsation cycle has been absent for about a year. Astronomers previously tracked this cycle by observing changes in Betelgeuse's light and surface movement, which illustrated the magnitude of the impact. Astronomers have now proposed a possible explanation. The star is slowly regaining strength, and the photosphere is also re-emerging. The star isn't undergoing its usual cycle. Instead, its interior is shaking like a bell that has been struck. A massive stellar surface mass ejection, never before observed, is occurring, and something is still happening that we don't fully understand. We can directly observe this unprecedented event and use Hubble to monitor surface details, providing real-time observation of how stars change over time. When will Betelgeuse explode? It's unlikely to happen in our lifetimes. It could occur tomorrow or 1,000,000 years from now. Will the Betelgeuse explosion destroy Earth? No, Betelgeuse's explosion won't impact Earth because it will occur too far away. Astronomers believe a supernova would need to be within 50 light-years to pose a danger, while Betelgeuse is over 10 times farther away. Instead, people on Earth will witness a dazzlingly bright star in the sky. Finally, scientists will have the opportunity to study the star in great detail when it goes supernova, since Betelgeuse is relatively close to us. Betelgeuse no longer appears in the night sky, so don't bother searching for it there. You wouldn't see much of it anyway unless it's in the August sky during the day. It's possible that Betelgeuse's light went out over 529 years ago, but we haven't seen it yet. Researchers eagerly anticipate witnessing Betelgeuse's massive explosion and subsequent recovery. While the Hubble telescope continues to monitor the star, NASA's James Webb Space Telescope may also be able to track Betelgeuse's material as it travels through space. Thank you for watching. Click the video on your screen to see more incredible space videos.